couple things here for number 4. This question is first asking, when is it defined? So we've already learned this as a special definition. When is it possible? We also have one of the most complicated math words there is in simplify. It's complicated because simplify means so many things in math. Simplify might mean add things together. If I said simplify 2 plus 3, you'd say, well, that's 5. Simplify might mean reduce your fraction to lowest terms. There is also special definitions for simplify in radicals. A radical is considered simplified if it is written as a mixed radical. So somewhere along the line, we've decided that mixed radicals are simpler than entire radicals. And you saw a reason for that in our activity before, because if I asked you to add 2 root 3 plus 3 root 3's, it's easy to say that it's 5 root 3's. It's simpler that way. But if I ask you for root 12 plus root 27, it's not as easy to say, oh, that's root 75. But if I do 2 root 3 plus 3 root 3, that's 5 root 3's. That's simpler to do. So that's part of the reason why for radicals, writing them as a mixed radical is considered the simplified way. So for part A, it's a square root, which is an even radical. We might have a problem with where it's defined because we can't take the square root of a negative number. But if I plug in a positive number here, can you see that the inside would still be positive? And if I plug in a negative number, because a gets squared, it's still going to be a positive number inside. So this one is always defined, and we would write that by saying a can be anything, any real number. Now, for simplifying it, we want to write this as a mixed radical. We have to simplify both the number and the variables. Can I simplify the square root of 45? Okay. Is there a perfect square that we can divide 45 by? 9, right? Because 45 is the same as 9 times 5. I'll keep the a squared here. 9 times 5 would be 3 root 5. The question now is, can I simplify the square root of a squared? Because square roots and squares cancel each other out, you would just get a. And something we learned from our absolute value part of our chapter is that square roots are always, when you figure out a square root, they're always positive. Now, for most of the math that you'll do from now on, if you wrote your answer as 3 times a square root of 5, most places that would be considered correct. That is the right answer. However, if we wanted to be even more technical, when you take the square root of a squared, this has to be positive. And the way that we can make it positive no matter what is putting absolute value bars around it. So our most perfect answer would be 3 absolute value of a to show that it's positive times the square root of 5. Whew. It's getting to all the complicated little details already, eh? So that's part A. Okay. So part B. We have a square root again. We can't take the square root of a negative number. If b is a positive number, is that okay? If you plug in a positive number for b, will you take the square root of a negative? Yes, you will. Because if b is a positive number, anything to the power of 9 will still be positive, but then it gets multiplied by negative 27, which is bad, because that'll be negative. So if b is positive, just showing my work here, that's going to be bad. What happens if b is negative? Is that okay? B is negative, that works. Because a negative number to the power 9 will be negative, times by a negative 27 will be positive. So when we want to say when is this one defined, this one is defined only when b is less than or equal to 0. That's when it's defined. Now, we have the square root of negative 27 times by b to the 9. Is there any perfect squares that divide 27? This is where your times table comes in really helpful. 27 is 9 times 3. So I'll go 9 times negative 3, and then I still have b to the 9. The square root of 9 will be 3. The idea being any time you have b squared, the square root of b squared is b, technically the absolute value of b. So how many b squareds are there in B9? Can you see that there's 4 of them, and there would be 1 b left inside? Okay, so the question is, why is it 4? Well, every time, if I have b to the 9 inside a square root, that is the same as b squared once, b squared twice, b squared 3 times, b squared 4 times, and then 1 more b. Because your exponent laws say you would add up your exponents. And that b to the 9, this is the same as b to the 9. 2 here, 2 here, 2 here, 2 here. And every time I have a pair of them, since the square root of b squared is b, one of them would get pulled out in front. So I could pull out 4 of those and write it as b to the 4. And then I would still have inside negative 3 times b. This is getting complicated. So some of you were asking whether the sequence stuff was the most complicated, and I said, depends. Some of this is a little bit more complicated. It really depends. Okay. Yes. The last one, when we wrote our answer right here. Well, there's a negative inside, but because b is less than 0, it'll make it positive in the end. Okay? Yes?
Average for which unit is the class average the lowest?
For part C, are you getting better at seeing where things are defined and undefined? Can you right away say, this is going to be bad if I plug in a negative number? So Z has to be bigger than or equal to 0. Because if you plug in a negative number, you'll take a 4th root of a negative. And this one's already simplified. The only way you could simplify the 7 is if you could divide by a perfect fourth. The smallest perfect fourth is 8. So there's going to be no way that you can simplify the 7. If you're going to simplify the variable, The only way that you could take a variable out in front is if you had 4 of them, and we only have 1 of them. So it's already simplified. So this one is done. And for D, first of all, because it's a cube root, it's always defined. And for simplifying this, does one of your perfect cubes divide 24? 4 isn't a perfect cube. 8 is. It's 8 times 3. And in order to pull out a y with a perfect cube, you would need 3 of them. Can you see that I can write y to the 5 is the same as y cubed times y squared? So the cube root of 8 is 2. The cube root of y cubed will be y. And what am I left with inside? A 3y squared. So this y cubed came out as the y. This 8 came out as a 2. And then what's left inside is the 3y squared. Just judging by the reaction, you may need to practice this a little bit. Number 10, 11, and 14.